Now we can talk about the blood alcohol levels. How do we know what the blood alcohol content is if we have access to testing the blood directly? So how would we detect it? The number one way that we would detect it usually is gas chromatography. That's the same test we used for doing drug testing, gas chromatography. So is that going to give us that's sort of the most widely used in a forensic lab. However, hospitals and clinical labs tend to actually do a chemical test called enzymatic oxidation. So essentially, they are chemically testing the blood sample and converting the alcohol in there to carbon dioxide and water and measuring the output. And they call a serum alcohol level. So it's testing the amount of level in the serum. There's a little bit of a conversion to convert it over to the blood. So the fact that the blood is made up of several things. It's made up of red blood cells, white blood cells, platelets, and plasma. And part of the plasma is the serum. So it can test how much blood is in the serum portion. And then I kind of have to say yes, but there might be more blood in the other factors. So it's multiplied by 1.16 to kind of say, okay, we tested this much in the serum. We multiplied by 1.16 to say how much was in the blood itself. So this would be, 250 is equivalent to, we divide the factor by 1.16. So 250 would be 215, which gets converted to a 0.215% blood alcohol content. So just for the most part, understand that if you're doing an alcohol test, a serum alcohol level, that there has to be a conversion factor to determining what is the blood alcohol level. So how do you collect and preserve the blood? Must always be drawn by a qualified individual. So under medically accepted conditions. So you have to use a non-alcoholic disinfectant, right? We can't contaminate the blood sample with alcohol, even though alcohol is usually used, when you're going to do an injection. Should be preserved in an airtight container after an anticoagulant has been added. So a lot of times you're doing a field test, so there's going to be a delay between when the blood is collected and when it gets tested. If it is put into an airtight container with the anticoagulant, it will retain the alcohol level. It's not going to decay and oxidize on its own. If not, it will oxidize on the way to the lab, and the lab measurement will not be precise. And it should be stored in a refrigerator. That cooler sample is going to hold on to it's going to slow down the natural oxidation so that it's going to preserve the alcohol in as it was when it was collected. So if it's not properly preserved, you're going to decline that blood alcohol level and result in low BAC readings. But if you preserve it properly, you're going to get an accurate reading. It does stay the same. Now, if it's a dead body that you're trying to test, as the body's decomposed, that alcohol may be produced, causing an elevated blood alcohol level. So all of these factors, as we said, this extra metabolism adds all sorts of extra factors to the task of doing the measurement. Is I have to be able to backtrack how much was in there, how much, how these are changing over time. So we have to do a lot of extra calculations. So there are charts that can estimate what your blood alcohol content will be based off of your consumption conditions. So these are based off your body weight, because your body weight affects how much water is in your overall body. It's how much food is in your stomach. Remember, that affects the absorption rate and the actual number of drinks consumed. So these charts are designed that you start at a body weight, you move over to how many ounces of 80 proof liquor, or you have to convert that if you're drinking beer or wine or something. What would that be? And then what would be the blood alcohol concentration? We're actually going to go through in class a task of doing an estimation, which is much more complicated than just doing this this chart. And this one has one chart for empty and one chart for full. We're going to do some calculations together so we see all the different factors that affect it, but we get the idea. This is another version this is basically what we're going to be working off of. The idea is that I have to subtract for each 40 minutes of drinking. If you think about this, if we have an average burn-off rate of 0.015, per hour. If I back that off to 40 minutes, it's 0.01. So this is the burn off rate. The idea is that as I'm drinking, my body has started eliminating. And then we have to have, okay, different kinds of alcohol consumed has different alcohol content, so I have to affect that. This one drink would be 1¼ ounce of a strong proof liquor, or 1 12-ounce beer, or 5 ounces of table wine. And then this is how many drinks, body weight in pounds. Note that this is not even taking into effect the full or empty stomach. So this is trying to kind of take a bunch of things in a small table to get an idea. But the big thing to look at is that this blue range, so this upper white range is fairly safe. This blue range is this, buzzed driving. Skills are affected, and there could be possible criminal penalties. In the state of Louisiana, we begin determining at 0.08. These are lower than 0.08. That doesn't mean that there aren't effects of alcohol, even though it's not legally intoxicated, considering, for driving under the influence. Between the 0.08 and higher, these are all illegal to drive, legally intoxicated with definitely criminal penalties. But down here, we start getting into these high, 0.3 and higher is in the lethal range. Your body just cannot handle that level, and it can't eliminate them fast enough. So the body just says, I can't operate with this much alcohol in the system. It's a poison. And so this is alcohol poisoning level. And again, it's not a rigid, you hit 0.30 and it's automatic. Some people might be lethal at 0.25. So there are different rates, but the idea of thinking of this as far as if you're in this range, this is seriously intoxicated medical issues. If you're in this range, this is legally intoxicated. You cannot be driving. In the blue range, you're still going to be affected, and you can see these results. So we will run through these in class. I have a couple of examples, and we're going to actually calculate under these conditions, what do we expect the blood alcohol content would be at the end of a certain amount of time of consuming a certain amount of alcohol, and get a sense of what would drunk look like.